Let me share my tutorial screen. All right, today we'll work on the tutorial 6, which is on discrete time Fourier transform. All right, for the first questions is not really a Fourier transform or Fourier series questions. Is test whether for your understanding of how you can sample the continuous time signals into discrete time signals. So what do I mean by sampling? I didn't talk about this in the lecture, but now I'll just roughly talk about it here. Let's say if I have a time signal, this is a time signal that looks like this, like a sine wave. And then now, this sine wave tells me that this is at time t equals to 0, this is at time t equals to 1, this t equals to 2, this t equals to 3. And now I'm telling you that I'm sampling this particular sine wave with sample of 10 hertz. All right, sample of 10 hertz. 10 hertz meaning that every 1 second, I have 10 samples. So the first sample will be here. All right, I draw the fifth one first so that I can easily draw the rest. So this is a second, third, fourth, fifth, maybe 6 here, 7 here, 8 here, 9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I should have one more actually before I reach 10. Okay, before I reach the number 1. All right. So between 0 and 1, not included the 1, I will have 10 different samples. So each sample you will know that is 0.1 second. Correct? This one will be 0.1 second. This one will be 0.2 second, all the way until 0.9 second. And then the next one will be 1 second. So this means by sampling. So I'm converting a continuous signal into discrete signal. This is what I have to do before I feed the signals to, let's say, microprocessors, or to feed the signals into any computer devices. So the signals will look like this. Let me draw out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is the signal that you always see. 6, 7, 8, 9, 10. Of course, there are more. All right. Now, in this question, it says that sampling frequency is 8,000 hertz. And then asks us to find out what is xn. All right. Now you see, if I have a 10 hertz signals, I am broken down the t by 10, right? So that I get each of them are 0.1, 0.2, 0.3, and so on. Now I have 8,000 hertz. How do I do conversion? Is that I need to break down this t by 8,000. I just need to divide this by 8,000. All right, so this is actually very simple. That's why I never talk about it in the lecture. So this will become cosine of 2 pi 1 over 8n, because now become n already, it's no longer t, plus 1/4 of sine of 2 pi 1 over 8n. All right, so if you write it properly, it will become cosine of pi n over 4 plus 1/4 of sine of pi n over 4. And this is the answer for the first question. It's already done. All right, just like this. Is to convert, or not say convert, but is to sample a continuous time signal. This one is continuous time into a discrete time signal. This is a discrete time. All right, no problem with this question. This is not really Fourier transform or Fourier series, just sampling. Second question, there are many sub-questions here, which I find it quite interesting. All right, find the Fourier transform of the following signal. You see, although I didn't write this is discrete time Fourier transform, but you look at the signal itself. It's all n, so you should know that it's discrete time Fourier transform. So same thing, outside I will not mention, when you go outside, when you need to solve a Fourier transform, they will not tell you whether it is discrete time or continuous time. You need to know it yourself. So let us try one by one. Xn equals to delta n. So can we have the formulas for that Fourier transform? Let me write it here. So Fourier transform is summations of k from negative infinity to positive infinity, where this is the xk and e negative j omega k. All right, so now we do A. A, our x omega is summation of k from negative infinity to positive infinity, delta k e negative j omega k. And just like I told you already, delta k is 1 when k is 0. All right, only has one value. And the rest of the value, let's say k equals to 1, k equals to 2, k equals to 3, or k equals to negative value, they are all zeros. So this whole expression is become just delta 1, delta 0. E negative j omega 0. In this case, it's 1. So that's the final answer. All right. Fourier transform of delta n will give you 1, which is the answer here. Now we look at question B. Now question B need you to use the properties of Fourier transform. Because we already know delta n, after you do the Fourier transform or discrete time Fourier transform, it will be 1. Now what if delta n minus nd? All right. Nd is just one constant. It can be any number like 2, 3, 4, or 10. And in this case, we need to apply the time shift property. All right, you can refer back to your lecture notes. When you have the x of n minus nd, your discrete time Fourier transform will just give you the e negative j omega nd multiplied by the Fourier transform of it. And in this case, what is the Fourier transform for delta n? Fourier transform of delta n is 1. Then we need to multiply by e power of negative j omega nd. All right, so therefore this is the answer. E negative j omega nd. Okay, so answer for second question for B will be this one. Now let us try C. Do I prepare more space for question 2? Oh yeah, I did prepare more space. So let us try C in this. How many space I prepared? Oh, I prepared 3 pages only. Okay, we try C here first. All right, in this small space. Now xn is equals to a power to n and then multiply by un. What does it mean? The a must be smaller than 1. So a power to n, when n is smaller than 1, will look like this. It comes from top and then go smaller and smaller because a is smaller than 1. But now you need to multiply by un. Un is all 0 until n equals to 1, then it's 1. Until n equals to 0, then it's 1. Okay, this is 0, 1, 2, 3, all the way. So when you multiply both graphs together, it gives you a graph that only starts at n equals to 0. Right? So this graph only starts at n equals to 0. And the trend is following a power to n. Right? There's nothing here. Everything negative side will be 0. Okay? Then this has many, many more. Okay, I just didn't draw out. All right, now we substitute it into the equation. X omega will be equals to summation k equals to negative infinity to positive infinity. A power to n un e negative j. Okay, in this case I use k, right? So it's k, it's no longer n. All right, the formula sometimes is k, sometimes is n, but it's up to you which one you want to use. They are the same. You just don't mix them up. All right, since I write here as k, so I will use k. Now, if you look at this signal, ak multiply uk, your signal only starts from this point and ends at infinity. So I can change my limit k equals to 0 to infinity, ak, and then I can get rid of this already. Because that is the information that tell me to change my limit from 0 to infinity. Now, this is not really the final answer yet, because it has so much expression. You can actually simplify it. How do you simplify? 0 to infinity. And this one is a e negative j omega power to k. And do you remember geometry series? Right, geometry series I write here. When you have AR square, all the way to all the way to AR power n minus 1, what is the formula? Or all the way to AR infinity in this case, not R minus 1. The formula for geometry series is A over 1 minus R, correct? All right, if you don't know this formula, please go and refer back to any mathematics textbook or from the internet. You just search geometry series or geometry progression. Then you'll be able to get this formula from the internet. And how to prove it, you can search for it also. So in this case, we get A is just the first unit, which is K. Okay, I write it down one by one. This one will be 1 plus, why is it 1? Because when I substitute K equals to 0, this one power to 0, anything power to 0 is equals to 1. That is why I put 1 here. So I write here, this is when K equals to 0. So when K equals to 1 is A e negative j omega. When K equals to 2 is A e negative j omega square, and so on and so forth, all the way to infinity. So our A is 1. Our R is A e negative j omega. So it's 1 minus A e negative j omega. And this is our final answer. Okay, this answer is much more cleaner than having a bunch of summation. Because this is just a geometry progression. You can have a final answers here. Okay, no problem. Now let us look at D. All right, here we are working on D. D, very similar, but now n is n minus 1. So what does it mean? N minus 1 starts when n equals to 1. So when it's 0, it's still at 0. It is still 0. Everything is 0. Even at 0. And when it's 1, then only it go up to 1. All right, so it's different from the n just now. So when you multiply it by the signals, that is like that, you actually get the signal that starts from 1. Let's say this is 0. Signal only start from 1. The rest are all 0. All right, so this one is A power n, U n minus 1. Now, again, we write into our equations, our formula, k equals to negative infinity to infinity, A n U n minus 1, E negative j omega k. Again, I use k, so everything has to be k. Okay, where's my summation? All right, now, just now you change your sign from 0 to infinity, right? Now it becomes 1 to infinity. Now this one, it becomes A e negative j omega k. All right, very similar to just now, except that now you don't have k equals to 0. So if you write this out now, you get A e negative j omega plus A e negative j omega square plus all the way. We can still use the formula A over 1 minus R, right? A is the first value. and R is the common multiplier. In this case, our first value is here. This is the first value. So we have A, E, negative J omega. And multiplier is the same thing. It's still back to this because you multiply by A, E, negative J omega every step. So is 1 minus A, E, negative J omega. And so this is the final answer for question D. So it's different from C because of the UN minus 1. Now the last one is the, okay, last one is what? A power to absolute value of n, or positive value of n. So what does it mean? So let us try to plot this graph out to figure out what does it mean. When n equals to 0, it's a power to 0, so it's always at 1. All right, so this is 1. When n equals to 1, it's a power to 1, but a must be smaller than 1, so it's decreasing. So here it's just like the normal a power to n graph. So this is just a power to n. But when you have a power to negative n, when n is negative number, it will become a power to n because you modulus it. You see the modulus sign here. So in this case, it is the same. When you have negative n number, it's same as a positive n number. So when you have 1, it's same as negative 1. When you have 2, it's same as negative 2, and so on and so forth. 3 and same as negative 3. So this graph is actually a power to negative n. All right. So therefore, we can split our equation into two parts. We have summation of k equals to negative infinity to positive infinity, a and e negative j omega k. Correct? Now, I split my summation into two parts. One part is here. Second part is here. All right, take note, second part include this one, include k equals to 0. So now I split my summation. Summation k, first part is k equals to negative 1 to negative infinity. All right, so it's a negative n, e, oh sorry, I use k now. A negative k, e negative j omega k. Second part is a summation from k equals to 0 to infinity, a power k, e negative j omega k. Now I can do one by one to find out the answer. The second one, actually, you don't need to find out, right? This one is same as our previous question, which is 1 over 1 minus e negative j omega k. If you still remember, the answer is this one. Now, first one. Now, you see, I have k equals to negative 1 to negative infinity. And I have negative k here. And I also have negative k over here. So why not I change everything to positive? So I can write it this way. I change everything to positive. I just swap all the negative k to positive k. Then 1 to infinity, a e j omega power to k. Now it becomes same as the second question is already, right? But second question has a negative here. But now I don't have negative there. So the answers will be a e j omega divided by 1 minus, sorry, there was the a here. Okay, 1 minus a e j omega. So now the final answers will just be both of them added together. All right, so the final answer is these two. 1 plus 2. Plus, I think is a plus sign, not a multiply sign. All right, so this is the final answer. Hey, there's no more k here. Why do I write k here? This is the final answer. Any problem with this question?
So
yes.
Like, can we actually put like k equals to 0 until negative infinity, while the other side start with 1?
Can
But
also.
Then we can't perform the steps until the final step, is it?
Okay. Then Okay, let us try that and see whether the answer is the same or not. Okay, I think this is a very good question, because I also interested to know the answer must be the same, but I want to know how to make it the same. So you are saying that this one start from 1, this one start from 0.
Yes.
Very good. All right. Now this thing again, we do the changing sign. All the negative become positive. All right. So k from -0 to -infinity become k from +0, because 0 is both positive and negative. So this k equal to 0 to infinity, we change the sign. This one, the same thing, j omega k. Everything changed to positive sign now. And in this part, this is exactly same as what you did earlier, right? So this part, I should write the answer, which is a e negative j omega divided by 1 minus a e negative j omega. All right. The difference from just now is that just now was 1. Now it's a e negative j omega, because I start from 1 now. So in this part, the first part, let me continue doing it. This one will be 1 plus a e j omega plus a e j omega square plus all the way. So this one become the 1, okay? 1 over 1 minus a e j omega. All right, now the final answer I write here, change a little bit. A e j omega plus a e negative j omega divided by 1 minus a e negative j omega. But I would say they are the same, because we can continue doing it from here. We multiply each others by the reciprocal, correct? Let me check. Let me think. Okay. What we can do here is that, oh, we just multiply one another. This become 1 minus a e j omega multiplied by 1 minus a e negative j omega. Here become 1 minus a e negative j omega plus a e negative j omega. And then you notice these two are the same, so you cancel it off. So the answer is 1 over the expression here. Previously, if we do it from -1 to -infinity, then the answer was here. Remember, it was e a j omega divided by 1 minus a e j omega plus 1 minus a e negative j omega. Now you see whether we can get the same answer. So we multiply the same thing at the bottom. Okay. Okay, wait, let me see. Okay, I did some multiplication wrongly here. I just noticed. Can I clear the whole page and then I redo again? Because I got not enough space. Okay, so just now, method 1 was my method. Okay, my method. Our answer was, do I still remember the answer? No, the answer was 1 divided by 1 minus a e negative j. Oh yeah, the answer was the other way. A e j omega divided by 1 minus a e j omega plus 1 over 1 minus a e negative j omega. Now we try to figure out e j omega 1 minus a e negative j omega. So this whole thing need to multiply by 1 minus a e j omega. So it's a e j omega multiplied by 1 minus a e negative j omega plus 1 minus a e j omega, correct? And now you see here, I can further expand it, a e j omega minus a square. Okay, now I'm doing this one. Hope you're not lost now. I'm doing this two now. A square e j omega multiply by E minus J omega. It becomes E0, correct? E0. E0 is just 1. So it's just A squared. Okay, just I forgot to do this step. Plus 1 minus AEJ omega, which is the bottom here. Divide by, okay, I don't want to write the bottom, the denominator. Then you notice that I can also cut off these two. So this one become 1 minus A squared divided by the denominator. Now, second method is what Kin Long asked just now. You arrive at this answer, 1 over 1 minus AEJ omega plus AE negative J omega divided by 1 minus AEJ negative J omega. Can we arrive at the same answer? The denominator is the same because it's just 2 multiplied together. I will not write it anymore. I'll just write this one. Then the top will be 1 minus AE negative J omega plus AE negative J omega multiplied by 1 minus AE J omega. So this is 1 minus AE negative J omega plus AE minus J omega minus A squared again, because EJ omega and E minus J omega will be just 1. Divide by the denominator. You notice these two also cancel out. We arrive at the same answer, 1 minus A squared. Denom. Okay? So both way you can do it. You can either do it from 0 to infinity, then the other side is negative 1 to negative infinity, or you can do 1 to infinity and the other side 0 to negative infinity. You will get exactly the same answer. Just that to prove that they have the same answer, you need to have some mathematics here only. Now, question 3. Okay, determine the convolutions of the following sequence using the convolution theorem. This one is an interesting question. If you want to do using convolutions, right? Not convolution theorem. Let's say I do raw convolutions. What I do? I write 3, 1 here and I write 3 1s here. And then I draw the table. This becomes 1, 1, 1, 1, 1, 1, 1, 1, 1. And then I draw lines. And this becomes 1, 2, 3, 2, 1. And where is my middle point? So this is the middle point, this is the middle point. So I extend both and meet one another. And so this one is my middle point. Okay? This is to do with normal convolution. But now this question asks you to use convolution theorem in Fourier transform. What is convolution theorem? Convolution theorem tells us that when I have x1n convolute with x2n, it is same as I have x1 omega multiplied by x2 omega. So now what we can do is that we convert each of them into omega form first, which is Fourier transform. And then we multiply the Fourier transform together. And then we do the inverse Fourier transform to find out this answer. Okay? It looks like a very long process, but this one is actually quite a good way to solve complicated signals. Because now this signal is just 1 on 1, 1 on 1 is very easy. Especially in continuous time, when you have signals that has mathematics expression, it's better that you convert it to Fourier transform, and then you multiply it, and then you convert it back to inverse Fourier transform to get the answer. So let us try. This one, to convert it to Fourier transform. So this is again the summation, k equals to negative infinity to infinity, xk e negative j omega k. All right, so x1 omega will be equals to, there's only k is from negative 1 to 1, right? And this is just delta k plus 1 plus delta k plus delta k minus 1. All right, I just make this into mathematics expression, which is exactly the same as your example in your lecture notes. If you forget the example, go back to refer to the lecture notes. E negative j omega k. Then do you still remember the answer? The answer was E j omega plus 1 plus E negative j omega, which is correct, right? It's like this, right? So this one will be, I just leave it as the answer. So this is x1 omega. x2 omega is the same thing, because x2 omega is the same as x1 omega, because they are exactly the same signal. Now, I want to find out the multiplication of them. x1 multiplied by x2. So when you do multiplication, let me write it here. E j omega plus 1 plus E negative j omega multiplied by E j omega plus 1 plus E negative j omega. You just do it one by one. All right. First, you do it these two. So it becomes E j omega multiplied by E j omega. So it becomes E j2 omega. Correct? Then you do these two. This one and this one. This becomes E j omega. Then you do these two. This one and this one. Just now we tried already. E negative j omega multiplied by E j omega is just 1. Now you do the second one. This one and this one is E j omega 1 and 1, which is 1. E negative j omega and 1, which is E negative j omega. Now the last one, E j omega with E negative j omega is 1. Just now we already tried. 1 with E negative j omega is E negative j omega. E negative j omega with E negative j omega is E negative j2 omega. All right, then now you tidy them up. I start writing from here, E j2 omega plus E j omega, E j omega. So plus 2 E j omega, 1, 2, 3, plus 3, plus 1, 2, 2 E negative j omega, plus 1, E negative j2 omega. Now you have x1 multiplied by x2. I want to find out convert it back to the inverse Fourier transform. So to convert back to inverse Fourier transform is quite straightforward here, right? To convert this back to inverse Fourier transform, just how you did in your previous question here already. Which is, where do you do it? I remember you did one in the previous question. Here, this one. All right. You use a time shift properties, you'll be able to convert it back to this one will just give you delta n plus 2. Okay, time shift property. Because 1 will give you delta n. So now you have 1 multiplied by ej2 pi will give you delta n plus 2. It's just time shift property. So this one will become 2 delta n plus 1. This one become 3 delta n. This one become 2 delta n minus 1. This one become, delta n minus 2. So there you go. You got the 5 delta already. If you want to plot out your output looks like this. This is n. This is when n equals to 0 is 3. And then this one is 2. And then this one is 1. This one is 2. And then this one is 1. Right? Exactly same as the answer that you do using convolution. Right? This one is to solve these questions using convolution theorem. So you need to do Laplace, the Fourier transform first, multiply them together, and then do inverse Fourier transform. You will be able to get the convolutions results. So this method is quite important. Most of the time, people will prefer this method than doing the actual convolution itself, except for this example. Where the example is too easy. So for complicated signals, you can do Fourier transform where you refer from the table. Let's say I give you Fourier, these two different signals. I ask you to do convolutions. Then you can use Fourier to get the, in Fourier, after Fourier is a sin curve, right? Remember? Then you sin curve multiply by sin curve. and then you refer to the table to do the inverse Fourier transform again. All right, so that is how they do complicated convolutions using the convolution theorem. Question 4. If the frequency response of H omega is given by delta omega, find the impulse response. Oh, so this one is doing inverse Fourier transform. All right, because this is from delta omega. I want to find out what is in time domain. So this one I need to do inverse Fourier transform or inverse discrete time Fourier transform. So easiest way would be, I would say, just do it from formula. Hn equals to 1 over 2 pi to negative pi. You just refer back to the formula earlier. Your delta omega. Okay, I like to use the other omega. Multiplied by E j omega k and then d omega. Oh, okay, I use n, right? So this one becomes n, d omega. All right, delta omega. Okay, now this is the complicated part. You want to integrate a delta. You want to integrate this thing. This is a delta omega. You want to integrate from negative pi to positive pi. What is integration? Integration is area under the graph, correct? But now this is all just a stick up. But do you remember what is the definitions of delta? Delta, let's say delta anything, delta omega. Delta omega, the definition is that this is a stick that is slim enough that the area equals to 1. All right, so it has a height of, let's say A, then the width of 1 over A. So when you integrate a delta signal, you actually get 1. All right, so this is a delta signal multiplied by Ej omega n. But you know, the omega can only happen at omega equals to 0 or omega equals to 0 because all others omega are zeros. You see, all here are zeros. Only at this point, it is at 1. So this whole thing becomes just delta 0, integration of delta 0. 1 over 2 pi, integration of delta 0, multiplied by Ej0, which is just 1, okay? And d omega. Integration of delta, just like I told you already, is just 1. So 1 over 2 pi doesn't matter the limit. Even if your limit is here, you still get 1. If your limit is negative, positive, infinity, you still get 1. So it's just 1. So this is 1 over 2 pi. This is the final answer. Right? So when you have an impulse signals in frequency domain, your time domain will be just 1 over 2 pi. This thing you can use the duality theorems to solve also. Remember our duality theorems? Let me clear this one. Remember the duality theorems that you did last week? It can apply here also. So we have we know that 1 will become delta omega. Sorry, the other way. We know that if we have delta n, it will become 1, correct? From our previous questions. So by doing duality theorems, 1 will just be, actually I can just tell it's the answer here already. It's 2 pi multiplied by delta omega. This is a duality theorem that tells us. You can refer back to the lecture notes that's last week. When I talk about duality theorems, it has a 2 pi here. If we use omega, it has a 2 pi. If we use f, then it doesn't have a 2 pi. So we usually use omega. So in this case, delta omega will be 1 over 2 pi because it just divide by 2 pi. So everything divided by 2 pi. Okay, then you should get the answer using duality theorem.
So,
Yes.
just want to ask, is it the properties for discrete time and continuous time Fourier transform, are they like sharing the properties?
Yeah. Actually, all the transform are the same. Later on, you learn about Z transform and also the Laplace transform. They are all the same, because these properties apply on frequency domain signals. Any signal that apply on that's in frequency domain, it will have this property.
Okay. Which means the property that state in the lecture slide is just like a few properties that probably relevant or might be useful to us, is it?
Yes. I didn't state all the properties. There are so many properties of them. You can go internet and check also. A full complete properties of Fourier transform, discrete time Fourier transform, Laplace transform, and Z transform. But they are all the same. Just that they maybe will phrase out in a different words, because one is in omega, one is in S domain, one is in Z domain.
Okay, just to confirm again, so for all the all the transform share the properties, even for Laplace transform, Z transform,
Yes.
and also Fourier transform.
Their properties are the same. Not say they share the properties, but they have the same properties. Let's say if Fourier transform has the convolution properties, right? Okay, I write here. Fourier transform, you have xn. Okay, let's say I continuous time, xt, yt, and in Fourier transform, you get x omega multiplied by y omega, correct? This is the convolution theorem. In discrete time Fourier transform, it's the same. Exactly the same. So discrete time Fourier transform, you get x omega multiplied by y omega. In Laplace transform, it's the same again. Let's say convolute yt, and you apply Laplace transform, and you get xs multiplied by ys. The only difference is that now I write it in s only, because Laplace is in terms of s, no longer in terms of omega, which you'll learn next week. Then in Z transform, again, it's the same thing. Z transform also is a discrete time signal. Then you will have the xz. Usually you write xz minus 1 multiplied by yz minus 1. They are all the same. All the different properties, they are same. Okay?
Thanks, sir.
No problem. You learn about Laplace and Z transform in the week 7 onwards. But for your quiz on week 8, the quiz is a graded quiz, 15% to replace your test. The quiz on week 8 only up to discrete time Fourier transform, meaning that only on week 1 to week 6. So I just write here first, quiz is week 1 to week 6. All right, so up to DTFT, up to, okay, means anything before that also included. All right, so it does not include Laplace, which you learn next week. Does not include Laplace.
So,
Yes.
sorry, I just asked.
No
So,
problem.
which means that quiz will be ABCD also? Selection also?
Yeah. It's a ABCD, just like your normal weekly quiz, but it's slightly more difficult question, and I have time limit for you to solve. So, on week 8, during your lecture time, I will say, let's say 4 p.m. right, but maybe not everyone can be there at 4 p.m. So we'll start at 4:15. At 4:15, I will release that quiz question. You can start searching it in times. The moment you click on the quiz question, it has a countdown timer of 1 hour. In 1 hour, you need to answer all the quiz questions. Okay?
So how many questions? Like 10 or 20?
Let me recall. 1, 2, 3, 4, 5, 6, 7, 8, 9, 6, 7, 8, 9, 10, 11. 11 questions. Okay. I can tell the questions structure here. All right. 5 questions on very short questions, meaning that all the theory questions, I say theory questions. All right. And then this one worth 5 points, okay? And then we have 2 questions on Fourier series and discrete time Fourier series, short questions. And then we have 1 long questions on Fourier series and discrete time Fourier series. If I'm not mistaken, it's something like that. All right. And then these 2 questions have 1 mark each, and this question is 3 marks. All right. So add up together to be 5 marks. So 5 marks on Fourier series or discrete time Fourier series. All right. Then the third one, you can guess it already. Same format. 1 mark, 1 mark, 3 marks. And this 5 mark in total is in Fourier transform and discrete time Fourier transform. Okay, clear? So you total of 15 marks. 5 on theory, and then 5 on Fourier series, and 5 on Fourier transform, including the discrete time one.
Sir,
Yeah.
which means there's no more quiz for week attendance, right? You're just doing this test, right?
So for the attendance quiz, I plan to stop it already because I find it useless to use attendance quiz where all of you attended my lecture. So I will stop the attendance quiz. I think week 6 is the last one, which is this week. So you will not see any attendance quiz anymore.
Thanks, sir.
Okay. So the quiz is an open book or closed book?
You are at home. I can't even see what you are doing.
Very honest, sir.
Very honest, it's open book. It's open internet. You can search internet for it. You are at home, but you have only 1 hour. That's the thing. All right. I trust you not to discuss this with your friends. Okay. You can search book. You can open book, open internet, open whatever. Okay, not open parents. Cannot ask your parents for this one. But I doubt your parents can, unless they are studying electrical engineering, or else they will not know about Fourier series and Fourier transform. But please don't discuss among the friends. Okay, open book, open internet, up to you. 1 hour limits only. So I don't want to hear any excuse that your internet down. Okay, I really don't want to hear that excuse. So try your best. Ask your parents, ask your family not to use too much internet that time so that you have enough internet bandwidth. But it's just an MCQ question. You should have enough. No, cannot discuss with me about the quiz. After the quiz can after you get all the answers, yeah. After the 1 hour, then we can discuss one question by one question.
So like after the quiz, right? Can I immediately know my result? Or
Yes. Because I'm using the time. So after the quiz, you will immediately know how many marks you score. You only have one chance. The moment you press submit, and there's a confirmation that confirm and submit, you press it, you cannot edit it anymore. Okay? No questions already, right? Okay, let us go to question 5. All right, xn be Fourier transform shown here. So this is in frequency domain. Okay, you see this is frequency. All right, omega is frequency. I want to sketch the signals of this xn. All right, now I know xn become x omega after Fourier transform. So now I want to know what is this xn multiplied by cosine of pi over 2n after the Fourier transform. What is it? Right, this question, I do not request you to do inverse Fourier transform to find out what is xn and then multiply by cosine and then do the Fourier transform again. But I was expecting you to use the properties of Fourier transform to do. So remember, we have all the time shift and frequency shift thing again. But now, this is cosine and this is cosine. Like, how do we even do the time shift or frequency shift? Any idea? All right. One way, you notice that, right? For frequency shift, let's say minus frequency shift, is actually your xn multiplied by frequency shift is e negative j omega d, correct? This is the frequency shift. I think I still need an n here. Yeah, e j omega d n, correct? This is the frequency shift property. Now you see, how do I change cosine to this? Can I use Euler formula again? I always like to use Euler formula. So cosine of this one is pi n over 2 will be equals to half of e negative j pi n over 2 plus e positive j pi n over 2. Correct? Now I can write this down already. x1n is equals to half of E negative j pi n over 2 multiplied by xn plus half of E j pi n over 2 multiplied by xn. Aha, now this one individually I can apply frequency shift property. So this become half of, the half is repeated. So I just write it down. E negative j, you see, is very similar now. So our delay is what? Delay will be pi over 2, correct? So I get x omega minus pi over 2. And then this one is x omega, and now it's positive, so it's plus pi over 2. You see, I already got my Fourier transform. Already got my Fourier transform. I cannot write equal sign here. I have to write Fourier transform like that, or discrete time Fourier transform. I already get it done already by using just a property. Now it says that determine and sketch. Okay, determine means this one already. This is a final answer for determine. Sketch. What does it mean? Let me erase off every other thing so that I can sketch it here. All right. I have omega and the magnitude axis. Initially is here from pi over 2 to negative pi over 2. Now, for the first one, let's say this is the first one and this is the second one. For the first one, I need to shift it to the right side by pi over 2 shifted. So instead of starting from the 0 in the middle, now it's pi over 2 in the middle. So it's here, pi over 2, and then I have the curve. And then this one end with pi. This is for the first one. And then remember, I need to multiply the magnitude by half. So instead of ending at 1, I will end at half. Now for the second curve, it's the same thing, but shifted left side only. Negative pi over 2, negative pi. Wow. Yeah, so that is my answer. So my answer is combination of 1 and 2 because it's added together. Okay, so that is the answer for question A. Question B is exactly the same method, but instead of pi over 2 is pi. So now this one becomes x minus pi and x plus pi, omega minus pi and omega plus pi. So I draw it in green pen here. So it means that it's shifted by a pi instead of pi over 2 only. So it's shifted here. That's all. Yeah, my triangle a bit weird. Okay, here. So this one is negative 3 pi over 2. And this 3 pi over 2. Okay, so second question is in the green color graph. All right, so that's all for the tutorial this week. Any questions? Yeah, no more already.
We're good.
Okay, good. Then I think that's all for today. Next week, Wednesday, we will have class on Wednesday because only Monday and Tuesday are public holidays. Please rest well during your public holiday, but don't go out very often. Then I will see you again on Wednesday. And don't forget to submit your lab report by Sunday this week, and as in the coming Sunday. All right, the coming Sunday, meaning in 4 days or 5 days time. Yeah, 5 days time. Please do not drag until the last second. Don't suddenly on Sunday night ask me certain questions. I might not be able to respond to you. Okay? You can ask me questions on weekdays like Tuesdays to Fridays. Okay? So if nothing here, then I will see you again next week. Thank you very much and bye-bye.
Sir.
Yes.
I just want to ask, because I did quite a few of tutorials. I mean, look back to the tutorials, and like, how do we determine the real or complex signal? I mean, in terms of equation, by just giving an equation, how do we know is real or complex?
Oh, okay. Complex signal has the J term. If you don't have J term, means that it's not complex signal. It's a real signal.
Oh, that's it?
Yeah, that's it.
So just basically follow the complex number. That's why it's
Yes, correct. That's why it's called complex signal. Usually in real life, complex signals do not exist. But in mathematics, they will exist. So the mathematicians put it down also. But complex signals, a lot of time they relate it to physical meanings. For example, they relate it to the electromagnetic wave from the sunlight, because electromagnetic wave from the sunlight is not 2-dimension, it's 3-dimension. So the third dimension, they put it as the complex dimension. So they can represent it in mathematics. So it's just from mathematics itself, you just see whether it has the J terms or not. If no J term, it's the real signal.
So we will learn probabilities at the end of this module, right?
Yes. There will be one lecture on probability.
Like
the lecture notes is
all
already
those
up there.
right?
You read the lecture notes, but I haven't do the recorded lecture yet.
Is it related to like density or all those kind of things?
Yeah, we have the spectrum densities that you need to calculate, the probability spectrum density, correct?
Oh.
But it's a very simple one. It's not like the mathematics module that you will learn, that mathematics student will learn. It's a simple introduction to probability. Miju, you have any question?
Yeah. When we change to the frequency domain, what does it mean physically? Like, we change to the frequency domain and then we plug in, like, it's a function of frequency, right?
Okay. So,
and when we plug in frequency, we get the amplitude of it, is it?
Yes, correct. So when we change a signal from time to frequency, let's say speech signal, okay, let's say this is some speech signal, you do Fourier transform. Basically, you do fast Fourier transform, which you will not learn in this course, but it's just a Fourier transform. You get a lot of frequency components. All right, okay, I shouldn't draw this one. Your frequency component will be continuous. All right, so this one is in frequency and this one is in time. You didn't change the signal at all. You are just seeing the signal in another perspective. So instead of seeing the signal in time perspective, you are seeing the signal in frequency perspective. The reason to do this is to enable you to identify what kind of frequency exists in this speech, let's say. This is how,
in like images, what does it mean by frequency?
Okay, in images, okay, let's say your signal is no longer like this. All right, images is 2-dimension. 2-dimension images is very complicated because you need to draw 3D graph. So let's say we have a strip of image, 1-dimension image, okay? This is 1 pixel times, let's say 100 pixel. All right, I use this as an example. Then each of this box is 1 pixel. Correct? This is how you do in image, right?
Yeah.
But image is 2D, but now I just change to 1D. Let's say this image is in grayscale. Because if it's not in grayscale, then it's again in 4-dimension already. All right, grayscale is only, okay, grayscale is, we call it the 2 dimensions. Not really 2-dimension, but grayscale has only 1 numbers. If it's in color, it has 3 numbers. So let's say we try to use the smallest possible so that I can write down the maths here. In grayscale, this particular pixel is black color, totally black. Totally black in grayscale is 255. This particular, let's say, is partially gray. In computers, is saved as 8-bit number 128, let's say. This one is totally white. White in computers is saved as 0 because it's an 8-bit system. So 8-bit, lowest number is 0, highest number is 255. All right, and then we have some gray one. Let's say this one saved as 100. And then we have some darker gray, and this one saved as, let's say, 150. Then this thing, you can actually plot a graph. When time, this no longer time, let's say n, the first pixel, n equals to number of pixels. When n equals to 0, which is the first pixel, is 255 is here. n equals to 1 is 128, n equals to 2 is 0, n equals to 3 is 100, n equals to 4 is 150. And then you just continue plotting it. Let's say it's like that. And then you can do Fourier transform. And Fourier transform, this is the discrete signal, aperiodic discrete signal. The Fourier transform will be something like that. Okay? It will be continuous. And most of the time, Fourier transform will have peaks. Okay? Why is it have peaks? Is because of noise and everything. So, okay. So let's say, what does this tell you? This is frequency. This one means high frequency, correct? This one means low frequency. It tells you that there are certain pixels, certain pixels that has big changes. Because let's say you have a signal that go from top to bottom to top to bottom to top to bottom. Then you have signal like this. This is the frequency, right? So it has big changes. If your signals is always small change, then you don't have any big changes. Okay, these big changes corresponds to the spike here also, how high your spike is. All right, the higher it is.
Variability in the grayscale value, is it?
Okay, so if this thing happen, it means that I have one pixel that is very high value together immediately with another pixel that is very low level, as in low gradient, low value.
Okay.
It is 255 and this one is 0. Then only this peak will happen because it has a big change. So in doing image filtering, they will use a low pass filter to get rid of this. So let's say you have
filtering is usually done through convolution, is it?
Low pass filter, yes, you can use convolution to do low pass filter also. Correct. You can, if let's say if implement it in the microprocessors, you will use convolution. It's basically a convolution theorem. Convolution theory, correct. So you convolute it with a low pass filter. But in frequency domain, it's just a multiplication. Okay. But then your time domain signals will always be the time domain signal. So let's say your face is here. And then you have a few pimples here. Then it analyzes, this pimples is black color. And then your skin is fairer color. It has a spike. So I filter off the spike. And then reconstruct your signals, your pimple is gone. That is how those face app works. All right, they try to get rid of all the high frequency noise. In that case, it's the pimples on the face. All right.
I think so.
No problem. Why so many people still here? Y'all can leave already, one? If no more question.
Sir.
Yeah.
Another one.
Can.
Which I realized. I mean, I just checked by the tutorial one solution. I found this. I don't understand. Can I share screen to show it?
Hold on. Let me allow you to share screen. Okay, I've allowed you to share screen.
Okay. So, like this part, right? I don't understand why is it equals after the modulus it become 1.
Because e power to j, no matter what it is, e power to j something. Okay, you write it in. Can you write it in the Euler's form? Let's say e power to j theta. You write in Euler's form. Or you no need to share it. You only have this question, right? Then I can write.
Yes.
It. Okay, then I will share. My screen. How to clear all drawing. Okay. Let's say e power to j, no matter what it is, let's say it's theta, you write it as what? Cosine of theta plus j sine of theta. How do you get this? Remember, this one is real part. This one is imaginary part. You get by using Pythagoras theorem, right? x
Yes.
plus jy, the modulus of, let's say z is this one, modulus of z equals to Pythagoras of x squared plus y squared, correct?
It's the magnitude.
Yeah, this one means magnitude, okay?
Oh,
Modulus means magnitude. So in this case, the magnitude will be cosine square theta plus sine square theta and square root. It will always be 1, no matter what the theta is.
okay,
Let's
okay,
say
understand.
EJ 100, it will be cosine square 100 plus sine square 100, and it will still be 1, because no matter what it is, this is 1. Okay?
Okay,
So,
okay.
so remember EJ something something, your modulus it always is 1.
Okay, thanks, sir.
No
Understanding.
problem. Okay, thank you everyone today, and I'll see you again next week.